Hello everyone. Today I'm going to be giving you an overview of my class Eecs 151, which is a class on digital design and integrated circuits. So you might be wondering why am I talking about classes all of a sudden? And that's because I like to talk about not just swimming, but like school's like an essential part, and it's like probably going to be these classes, especially 151, could potentially be my future. So I'm thinking, yeah, maybe let's talk a good amount about these classes. So today I'm going to kind of be covering a slight overview of the things of like kind of devices that we use, and then we're also going to be talking about lab about all the labs that I've done and where I'm going next in a class. So let's kind of start off with a couple basics. Like obviously I'm not like trying to test you in anything. I'm going to try to explain to you in like very simple English here. We're just going to go over a couple of devices: the mux, the latch, and a flip flop. So the mux you can kind of think of it as like you have a select bit, which is basically you can think of the select bit as like your traffic controller. It's like probably have like a couple of input ports, and the select bit kind of just bit or bits kind of determine do you want like you know do you want this input to come in, or do you want this input to come in, or do you want this input to come in, or whatever, however many inputs you have, and like whichever input you choose, that's going to be the output. You can you can use an AND gate. You can use smaller muxes. You can use a decoder and encoder, which is still something I'm trying to figure out how it works. Even though I like technically should know it, but that's kind of that's gonna be for later. And then like you can see that's how muxes work. Now we're going to be kind of talking about a latch. So the latch you can kind of think of like you have the enable signal. And it's basically kind of like you can think of it as like a gate. The enable gate is kind of like your security guard. And he says like sometimes I will start letting people through. And it's like maybe the room is full, and then the enable says no, I don't want anyone to pass through, so I'm going to have a latch. You cannot pass through. And when enables, and then probably people will start leaving, and I'm like, okay, I want to enable people to come back through. And that's kind of how a latch works. Unfortunately, Verilog doesn't like latches because of what I'm going to go to next. But you can think of it as like, latches aren't really synced up with the flip flop. And as a result, you might be getting some kind of really wonky stuff. You might be getting some really wonky stuff in your input, and then that can like kind of screw up everything else. So that's why you get a warning. And that's exactly what is happening to me right now for the last lab that I'm doing, and it's the reason why me and a bunch of other students couldn't finish it, thanks to this team, thanks to latch inference. And finally, we're going to be talking a little about the flip flop. The idea of the flip flop is that like maybe I don't want to update my signal every time because my idea of thinking why we need a flip flop, we have a clock, but everything takes a certain amount of time. You think your computer runs like super duper fast. Well, you can still only run so fast because like obviously your signal has to travel through a wire, and also like all these logic gates, these AND gates, these OR gates, these like the muxes, that all takes time, right? And when that happens, like you don't want to get like let's say I have your start and then you have your end. Obviously, you don't want like your end to pass through like the wrong signal because that might set off a chain of like wrong signals in the future. So what happens is that you basically have to wait for the correct signal to get passed through, and then you can update on the next one. And that's kind of what leads into the thing something called the critical path, which is a little out of scope for this kind of mini lecture. But anyways, that's kind of an overview of some of the tools that you learn when you're in this class. Now we're going to be talking about the labs. So in each 151, there's like the lecture component, which is relatively chill, and then there's a lab component, which is 2 units. But if we're being real, it's more like 4 or 5 units of work because these labs take like a lot of time. Like seriously, each of these labs are basically mini projects, and you have 6 labs. The first lab is kind of like your setup. The setup seems, you might think, oh, it's pretty chill. until you run into an issue, and you're like, how the hell do I set up? The hell do I fix this issue? And you're like going to the TAs, and you're like, oh shoot, what is going on? Maybe I have to restart because I didn't quite read the instructions that well. And then you got a basic Verilog task. You're trying to get familiar with it, and then you're checked off. Then you go into something called the adder, the waveform. The waveform eventually is really cool. I only started getting really familiar with the waveform after this lab. I probably should have gotten familiar with it much earlier, but that's just kind of me because I sometimes learn a little slowly. But basically the idea is you have an adder. You have to write the adder in terms of logic gates, and then you use a waveform to perhaps debug it if it's not working. And after that, you have a counter. The idea of the counter is that perhaps every clock cycle you're going to count up. You're going to count up from 0 to 16, and then afterwards you're going to go back to down, and then go up. But then you also may want to stop the counter at some time, and you'll have to probably keep that track up. So that's lab 2. And lab 3, this is kind of when things get a little wonky. So lab 3, the idea is that ultimately is that first 2 tasks you have an edge, async. You're trying to hook up an async signal to synchronous signal, and then you also want to have an edge detector, which is kind of okay. And then you get to something called the debouncer. So the idea of the debouncer is, let's say you have an input. Your input obviously, I'm gonna do this. Hopefully you can see it. Your input might just be absolutely wonky, and when your input's absolutely wonky, your Verilog probably doesn't like what you're doing. So the idea is that you want your input to be at least stable for a certain amount of time, because you might press the button 1/10 the way or kind of the way. Maybe you pressed it, you didn't quite press it. So you want it to be at 1 for at least a certain amount of time, probably 1/10 of a second, and then the debouncer will make sure that happens, and then it will allow a signal of 1 to be passed through. And then after that signal of 1 is passed through, that is where you get to the DAC and the square wave. Idea of the DAC of that is that you have a high and low. Have a high and low. Is that you kind of have a high and low, and that kind of stuff eventually will generate a square wave, which you'll play, and it'll be kind of da. Yeah, it sounds kind of awful, but it's kind of cool, when you got through that lab, and you get to play your audio through that board. Yeah, you know what I mean. So now we finished lab 3. You thought that lab was bad. Well, guess what? You're in for an even rougher ride. Lab 4 is gonna be lab 3 on steroids. So what happens in lab 4 basically, let's say you want to play a note, and then you have to be able to increase, decrease exponentially, increase, decrease frequencies within a certain range. You don't want to go too low or too high for frequency, because otherwise, if you go way too low, yeah, that would not be good. And then you also want to create a sine wave, because we don't like square waves. Square waves suck. They're harsh and they sound and they pierce your ears. So we get to implement a sine wave. And after that, with the sine wave, that's where we get to the FSM. Yeah. So if you don't know what an FSM is, the FSM is you kind of have a bunch of different states, and based on certain logic, based on your input and what state you're in, you'll probably transition to another state. Yeah. And the idea is that you have a bunch of different states. You probably have one state where you have notes playing da 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 da, and another where you're going backwards, and then you can pause, and you can also go to a state where you can change one of the notes and make it sound really high or very low. I myself really struggled, probably a lot of us did, and I remember literally testing does this work? Oh shoot, it doesn't work. Like I remember like trying to check off for lab, the TA literally saying, "Nope, you're not there." And then I tried checking off again, and I was like, I was really close. Thank God another TA was just like, just go on. I think you're pretty much there. I can't fix your issue. Well, you can just go on. Yeah, yeah, Henry. What are you? Okay. Anyways, now that lab four is finished, we got five. You're done with more than half of it. Woohoo! Okay. Now you're at lab five. Now when you're in lab five, you get into some kind of cool stuff. You kind of have, in lab five, you have like a UART, and then you have kind of like, I guess you could say, you could kind of think of it as like your output, as or like you can think of the UART as like the keyboard and screen, and then you can think of like the other, and then you can think of your RAM control, your RX. Wait, what am I talking about? Yeah, you can think of something else. I forgot the exact name, but and then that is kind of like you. Yeah, yeah, it's like you. Yeah, and then you want the UART to transmit information to you, and you want to transmit information to you. Obviously, you can't transmit infinite amount of information, so you have to kind of decide like when can I implement this and when can I not? When can I transmit and when can I not transmit information? And that's kind of how this lab goes. There are some instances like where you can transmit, and other times when you just don't want to transmit. Perhaps perhaps you are transmitting information already, and they're busy, and it's like you want to give information to them. No, you can't. Or maybe they're ready to give it to you, but like you're overloaded, so then you're like, no, I can't give information to them, and then that kind of also stems. This is also connected to what we call first in first out. And first out sounds exactly like how we think of it. You basically send signals in. You can think of it as like a queue. You send things in, like you send this packet in, and it's like if you want to read, this packet gets read out first. And also make sure to keep track of like being empty and full because you don't want to read from something empty and you don't want to write to something that's full. So that's basically a lab five. It was a kind of a nice break after the previous two labs, which basically took up essentially all my time. But if I thought lab five was chill, we're on lab six. I still haven't finished it. Probably should be done with it, but unfortunately, that's kind of 151. So what happens in lab six? The idea is that you have a keyboard and you want to write from the keyboard to the screen. And how that works, you kind of have a UART, and then instead of saying you here, you're gonna have like a memory controller. Yeah, so you kind of have a memory controller, and from the memory controller, the idea is that like you will first write a data bit, to the computer, and then that bit would get stored in the memory. If you keep writing a bit, it's going to get stored in the memory again, passing through the FIFO. You don't notice it because it passes through really fast, and because it passes that fast, and that's kind of how things work. But all that stuff is going on behind the scenes, and now let's say I want to read. Well, if you read, theoretically, what should happen is that you take the value from the memory controller, get sent up to the screen, and it displays what it should be. Unfortunately, my thing is still not quite working, which is sad. I kind of wish it was working, but perhaps that's just me being a bad engineer. So who knows? But that's kind of the overview. So now we finished all these labs, right? You're done with these labs. These labs took way more longer than perhaps you wanted them to, but nope, you're not done. Because guess what? Now we got our final project. So the nice thing about the labs is they kind of build different components of like the FPGA. I think of this as like your input. This could kind of think of it as like your audio. This is kind of like the basics. Maybe you could think of it like that. Now you're kind of like Now it's like basically, let's say now it's basically, yeah, you have like a bunch of instructions. You want the instructions, and you want all these instructions to be run through your CPU pipeline. This is from RISC-V, which we kind of already did a little, but now we're going to be doing a much bigger scale project of what we did back back in 61C. So this is going to be a lot of work, and you have to work in partners. I will say, honestly, my partner has kind of been carrying me. Yeah, yeah, Henry, why are you such a bad project partner? Well, okay. So what that means, because I decided to pair up with someone who's absolutely crap, it also means I myself will probably have to put in more effort. Or otherwise, even if my partner carries me, maybe we get past through everything. Maybe we even wouldn't like get up to a podium. But I'm going to feel pretty upset if I don't feel like I at least did something to get the project going. And as a result, this is kind of the reason why I myself want to catch up and why I also like to talk about the class, because talking about it also makes me feel a little more comfortable and makes me realize what stuff I myself am kind of stuck on. So hopefully you got to learn something. I'm probably going to talk to you a little more about our project later on, like who knows, maybe a week, two, or maybe when we're done. But I hope that you all enjoy watching this, and maybe you'll want to learn a little about digital design. I mean, if you're an Eecs major or if you just want to learn about this stuff, hopefully you learned something. Thanks for watching. Take care and see you next time.